Hi guys, this is section 7-8 on negative rational exponents. Remember the word rational means fraction. So we're going to deal with some exponents today that have fractions and are actually negative. So it's going to be a good lesson, a lot of review, kind of combining all the topics we've learned so far. Let's talk for a minute about how x squared and x to the negative 2 are related. If you remember, when you have a negative, that's not really allowed. So what we do is we take x to the negative 2 and we move it down below and it becomes x squared. So how are x squared and x to the negative 2, which can also be written like this, related? They are inverses of each other. Reciprocals, okay? So what if I have 1 over x squared and 1 over x to the negative 2? There are two ways to think about this, but this negative is going to flip our fraction, okay, and then it will drop out. So here we have 1 over x squared. Here I have x squared. Again, they're reciprocals. When you have a positive and negative exponent, and they are the same thing, they are going to be reciprocals of the base, whatever they are. Okay? The other way you could have thought of this problem is you could have kind of attributed this one in here. So I have 1 to the negative 2 over x to the negative 2. Then you could have flipped it x squared over 1 squared, which is just x squared. There's lots of ways to think about it. But if you have one exponent that's positive and one that's negative, and the bases are the exact same, you are going to have reciprocals of each other, inverses. Okay? So, if I have x to the 2/3, what does that mean? If you recall, this is the exponent, and 3 is the root. Okay, so we could think of it as x squared to the 1/3, or the cube root of x squared. Because 2 times 1/3 is 2/3, so I did not change the exponent. I can break this x to the negative 2/3 down even further, okay? First of all, the answer is going to be the reciprocal of this, so it's going to be 1 over the cube root of x squared. I know this because they should be reciprocals because one is positive, one is negative, and they have the same base. But let's talk about how we get there. You have x squared to the 1/3 and also to the negative 1. That's power to a power to a power. You'd multiply them all together and get negative 2/3. If this is the case, this is going to invert us right away. So I have 1 over x squared to the 1/3. And that's 2/3, which again is where we just were at. Okay, so let's do some review here. I should have grabbed my calculator. Okie dokie, here we go. 343 squared, they're going to go ahead and tell us what that is. So now let's talk about 343 to the 5/3. We're going to do the 1/3 power first because 343 to the 1/3 power is the same thing as the cube root of 343, and that is 7. Oh my gosh. I hate when that happens. Okay, so this is 7, and that will be 7 to the 5th power then. 7 to the 5th power is just what they said, 16,807. So here we're going to use that fact that the cube root of 343 is 7 to get these different values. That will be 7 to the 4th, just 2401. It makes sense that this is less than 5/3 because 4/3 is less than 5/3, so that 343 to the 4/3 should be less than 343 to the 5/3. Oh, I know this one. That's 343. 343 to the 1/3, we already discussed that. That is 7. 343 to the 0 is 1. 343 to the 2/3, that'll be 7 squared, that is 49. Okay, now what if I have this negative, okay? Well, 343 to the negative 1 is just 1 over 343. 343 to the negative 2/3 is going to be the reciprocal of 343 to the 2/3. It's going to be 1 over 49. Let's talk about why. This is going to, we need to make this positive, so that becomes 1 over 343 to the 2/3. And then cube root of 343 is 7. 7 squared is 49. Same thing here. It'll be 1 over 343 to the 5/3 to make that positive. 5/3, we already did it, 16,807. That is the value. Okay, 343 to the negative 4/3 is 1 over 343 to the 4/3. Go back to our chart, 2401, 1 over 2401. And wrap this up here. 343 to the negative 2 is the same thing as 1 over 343 squared, which is 1 over 117,649. Okay, so really that negative rational exponent is just moving it down below and then taking care of that rational exponent just like we did in the last section. There are 3 ways in which to solve. It does not matter the order you do the 3 parts. And I'm not going to go all the way through this. I just want to address this column right here. If I take 27 over 1,000 to the negative 2/3 power, I could invert it first, in which case I would get 1,000 over 27. Then do the 1/3 and then squared, okay? I could take the cube root first. If I take the cube root first, I think I get 3 over 10. Then I can square it, then I can invert it. Or I could square it first, which I never would do because that's going to be really large. 27 squared, 729 over, now I'm going to have 6 zeros. Then take it to the 1/3 power and then invert it. The order doesn't matter. I prefer these 2 routes personally because when you square things, the numbers generally get bigger and it makes things a little bit more confusing. But it does not matter. Your answer will wind up the same. Okay? How do you solve equations here? Okay, you're still going to isolate the exponent and then raise both sides to the reciprocal power. So in this case, I want to get y by itself. For y to be by itself, I need y to the first power. To what exponent can I raise both sides to get to the positive 1 power? It's going to be to the negative 3/2. Negative 2/3 times negative 3/2 is y to the first, which is what I'm looking for. I also need to take 16 to the negative 3/2. That's going to be 1 over 16 to the 3/2. Square root of 16, I'm going to do that first. Square root of 16 is 4. That's 1 over 4 to the 3rd. And 4 to the 3rd is 64. So y equals 1 over 64. Okay, 30, I'm going to divide both sides by 6 first. 1458 divided by 6, that gives me 243. V to the negative 5th equals 243. I'm looking for v to the first power. To get v to the first power, I need to multiply both sides by negative 1 over 5. Can't tell that's negative. Not multiply both sides, I'm sorry. Raise both sides to that power. It does look like I'm multiplying because it's so big. Okay, if I take 243 to the negative 1/5, that's taking 1 over 243 to the 1/5. 243 to the 1/5 power is, I didn't type that in right. Yeah, 3. So that's going to be 1/3. So v equals, in this case on 30, v equals 1/3. Okay, I'm going to clear some space here because I'm a little sloppy. Let's talk about this one, 32. First thing I'm going to do is subtract 5 from both sides. M to the negative 3/2 over 3 equals 9. Multiply both sides by 3. M to the negative 3/2 is 27. I need m to be to the first power. Okay? To get m to the first power, I'm going to take both sides to the negative 2/3 power. When I multiply that through, I'm going to get positive 1, which is what I'm wanting. I'm going to take the cube root of 27. Actually, I'm going to take 1 over 27 to the 2/3, so I don't forget. Cube root of 27 is 3. 1 over 3 squared is 1/9. Okay, I hope that makes sense. If it doesn't, jot down some of these. Ask me tomorrow. We will go over them. Okay, how do you evaluate these in your head? Again, it doesn't matter. I do prefer and tend to do the negative exponent first. Go ahead and invert it. That is up to you. Okay, on this example, I would have 1 over 125 to the 4/3. I'm going to take the cube root first. The cube root of 125 is 5. So now I have 1 over 5 to the 4th. And I get 1 over 625. 36 to the negative 3/2 is 1 over 36 to the 3/2. Square root of 36 is 6. 6 to the 3rd power is 216. Okay, I'm actually just going to go straight down this column. Negative 4/3, I'm going to take 1 over 64 to the 4/3. I'm going to take the cube root of 64, or 64 to the 1/3 power first, which is 4. Get 1 over 4 to the 4th, which is 256. I am typing some of these. Oh, great. Here it comes again. I am typing some of these exponents in my calculator because I don't know them all. I could act like I did. You might have more respect for me then, but it's not true. I don't want to lie. Okay, 625 to the negative 1/4 power is 1 over 625 to the 1/4 power. 4th root of 625, or 625 to the 0.25. 5. I just did that. I should have known that one. 1 over 5. I'm a little lazy. Okay, this is a little different because I have a fraction to a rational, negative rational exponent. So I'm going to take care of that negative first. So I'm going to flip my fraction. 49 over 25. Now it's to the positive 3/2. I'm going to go ahead and square root both top and bottom first. And I'm going to get 7/5 to the 3rd power. 7 to the 3rd power is 343. 5 to the 3rd power is 125. Okay, 9 through 13, I'm going to create some space here. On 9 through 13, please realize that only the second part has that exponent with it. The first part does not. So I 6 times 1 over 32 to the 4/5. 5th root of 32 has to be 2. So it's 6 times 1 over 2 to the 4th. 2 to the 4th is 16. So I have 6 times 1 over 16, which is 6 over 16, which they had the 2 in common, 3/4. Okay? 4 times 1 over 16 to the positive 3/4 now. 4th root of 16 is 2. 4 times 1 over 2 to the 3rd. 2 to the 3rd is 8. 4 times 1 over 8 is 4 over 8, or 1/2. Okay, 13 is very similar. It just has a little bit bigger roots, so you might have to break out your calculator a little bit, even though it says evaluate in your head. Nobody will know. Just keep it a secret. Okay, how about if you have these variables? What do? Okay, everything is the same. You're still going to add, subtract. You're just dealing with fractions, okay? So negative 15 over 5, that's going to be negative 3. They don't want negative exponents, so we're going to have to get rid of those. I'm going to take this x to the negative 10. I'm going to move that up here. Or you could have thought of it as 7 minus negative 10, which becomes x to the 17th. The y to the negative 2/3, that needs to go down below with the y to the 1/3. Or you could have thought of it as negative 2/3 minus 1/3, which is negative 1. So we're going to have a y to the first power down below. Okay, a over b to the negative 1/2. I'm going to take care of the negative exponent first. I'm going to invert my fraction. B over a to the positive 1/2. I think you can just leave it like that. They just don't want negative exponents, and that's not one. Okay, e to the negative 2/3. Positive exponents only, so that's going to be 1 over e to the 2/3. V to the negative 1/2 times w to the 3rd. This is not okay, so I'm going to move that below. W to the 3rd is going to stay up top because it is positive and it is okay. V to the 1/2. Okay, I don't know if you can read 23, so I'm going to rewrite it. I have a to the negative 4/5 over a to the 6/5. This is not okay, so I'm going to move that down below. So it's like 1 over a to the 6/5, a to the 4/5, which you add in that case, which is a to the 10/5, which is 10 divided by 5, a squared. So it's 1 over a squared. You could have also thought of it as negative 4/5 minus 6/5, which is negative 10/5, which is negative 2, which ends up right here anyway. Okay, how do you do these? Same as you would if it was a non-fraction, okay, an integer. What you're going to do here is you have the same base, multiply is the product. We're going to add those exponents. So I'm going to have 4/3 plus -1/6 equals x. Okay, I need the same base. So I'm going to change that to 8/6. 8 minus 1 is 7/6. That's what x is going to equal. Same thing for 26. Same thing for 27, except you're going to have to solve here, in this case, subtract both sides. We didn't go any powers to a power. What you do here is you're going to multiply through. I have m, 2 times -3/4 is -6/4 or -3/2. You can reduce the fractions. N to the -12/4, which is -3. I'm now going to take care of those negative exponents. 1 over m to the 3/2, n to the 3rd. And that goes up there. Okay, why don't you look at those? You'll have time to practice those more tomorrow in class. And that's it for today. Okay, thanks.